Hey, what's up? It's Vigil. This is my stream journal. The date is 7:13. The time is 22:30. I just wanted to cover something really quick. People have a common misconception that when you travel faster than the speed of light, you're going back in time. That's not what's happening. Light travels at a finite speed. It's not instantaneous. So essentially, if you're 10 light years away from a planet and you're traveling faster than the speed of light, what's happening is you're not going back in time. What you're doing is you're going through the light field faster than you normally would have. So you get the Doppler effect. So like as you accelerate towards a planet and you start speeding up, the hue coloring of the planet will begin to change. And what this means is that as you pass through the light field, you start speeding up past the speed of light, it starts compressing onto the windshield, and your lumen rate or your voltage type mechanism of light lumen or of a light particle will increase, and so the energy on your ship will start to heat up, and like you'll start to see things move faster. It's like moving through a TV or like playing a TV faster because you're pressing into the light field, and like you get the Doppler effect, the hue changes and whatnot. And it has this effect. As you're traveling towards the planet, say it takes you 1 year to get to a planet that's 10 years away, you shoot off to it, you see 10 years of the past from this planet, and then you arrive at the planet, and you tell other people what you saw because you had a camera on the front of your ship recording everything, and they go, yeah, we did that like 10 years ago. And like, but then you can turn around, shoot back to the other planet, get there ahead of the other of the 10 years, and so like you get there in 1 year, you turn around instantly with the recordings, you come back to your original planet, and then you can show them the footage of what they'll see over the next 8 years as the light finally makes it to its destination. It's a field of lumens, or it's a field of light. You're not actually traveling time, you're going into the past, picking up the data faster, and then shooting back and showing it before the light actually reaches the planet. So you're not going back in time, you're not time traveling. It's super important that you understand this, because like fast and light travel, it won't allow you to time travel. You can't time travel by moving forward super fast. Like, it just doesn't work like that. You have to warp and bend space-time essentially. And like, so it's a common misconception, and it's like you read physics books and they talk about how like the relative time of the two clocks will alter as you like start to accelerate past the other person, shit like that. They don't really understand what they're talking about. Like if you have two astronauts and they're headed towards each other, and you can say, well, like this person's clock is moving faster than this person's clock relative to them viewing each other, it's not reality. It's not correct. What's happening is, well, one, what's moving is a perception thing. Like it's like being on a train and you can't tell if you're moving or that train is moving. So if you're moving through space and there's no objects around you to determine how fast you're moving past something, and it's just an empty space you're traveling through, and the inertia doesn't change, you're sitting still in your perception, and if something appears, it'll look like it's moving even though it's you, it could be you moving. And it, like, so like, and then the idea that like these clocks will resync, it's just not correct. What's going on is that you're not going into the past, the clocks aren't resyncing, you're moving further away, you're creating a field distance that requires time for the light to travel through it, and then if you turn around and come back through it, you're pressing into the light field, and you're seeing things compress as you move faster than light through the light field, or faster than the light than when you're moving away from it. It's like the Doppler effect. But like, so light at any one point is in a position, and then it moves to another position over a unit of time, and another position. And if you're blazing through it in a spaceship, you're essentially like, if this is a light photon, this is a light photon, this is a light photon, and they contain the last three units of time, and you're blazing through it faster than the speed of light, you're essentially just going bam, 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 and compressing these light photons into each other. It's a light field, not time travel. Anyways.